So now let us go over preparation of carboxylic acids. So in your syllabus, there is preparation of carboxylic acid by oxidation of alcohols and aldehydes. Next is by Grignard reagents, and third is by hydrolysis of nitriles. So we'll go over the first preparation of carboxylic acids by oxidation of alcohols and aldehydes. Just write Ca here. By oxidation of alcohols and aldehydes. This is very interesting, and we'll go in depth here. So in our previous class, we saw that there are 5 oxidation levels in organic chemistry. Starting from alkane oxidation level, next we have alcohol oxidation level, next we have aldehyde oxidation level, 4 we have carboxylic oxidation level, carboxylic acid oxidation level, and 5th we have carbon dioxide oxidation level. So in our previous classes, we had gone through a few examples of reduction of aldehydes to alcohols. Okay, so there we had used, to reduce them, we had used reducing agents. If from aldehydes to alcohols, so we had used something called reducing agents. So, but if we have to go from alcohol level to carboxylic acid oxidation level, or from aldehyde to carboxylic acid oxidation level, we need oxidizing agents. So here the more fundamental idea was that reduction requires addition of electrons, and oxidation requires removal of electrons. Another way to put it would be, in reduction there will be addition of hydrogens, hydrogen atoms, and or it might also mean removal of heteroatoms. While in oxidation, it means removal of hydrogens. It can also mean removal of hydrogens, or addition of heteroatoms. if we need to oxidize alcohol, so this is our primary alcohol. It is very easy to remove OH proton. This proton, the OH proton, can be very easily removed. You could use simple base to remove that. Any basic reagent would do. However, it is very difficult to remove the CH proton. So it's very difficult to remove CH proton as well with the pair of electrons. If you have to remove this proton with the pair of electrons, it's very difficult. So some reagent that can remove hydrogen atom and a pair of electrons, we need those reagents, and that defines our oxidizing agent. So our aim would be to remove the hydrogen atom and this pair of electrons. So let us go over oxidation of primary alcohols using chromic oxides. So the best oxidizing agents are metals that have at least 2 higher oxidation states. So that means transition metals. For example, oxidation of primary alcohols using chromic oxide. So this is our primary alcohol. And chromic oxide, note that chromic oxide, the oxidation state is in its +6 oxidation state. So it's going to form chromate ester. So what could be the possible mechanism here? Just go through the possible mechanism. Any base, so base is going to abstract this proton and it's going to give you So this is going to attack highly electron deficient chromium metal. So this is going to take the proton here and base is regenerated. So what we have now is chromate ester. I'll erase this. The CH proton, this proton, is removed by cyclic mechanism on the chromium 6 ester. So this is going to abstract this proton, this bond will fall back, and this pair of electrons will fall back on chromium. So what this will give you will be aldehyde plus you have reduced chromium from +6 oxidation state to +4 oxidation state. So meanwhile, you have reduced the oxidation state of chromium from +6 to +4. Meanwhile, you have oxidized alcohol from alcohol to aldehyde. So further, this can react further, and so let us show it here. Our aldehyde, which was formed, can hydrolyze to form hydrate. So this is hydrate. It's also called gem diol. So let us say base is going to take away this proton. So what we have is and that is going to attack The electron deficient chromium atom fall back. This will fall to oxygen. So this negative charge is going to attack the proton. Bond will fall back. And this pair of electron falls back on chromium. So what you have essentially done is you have oxidized it to aldehyde is oxidized to carboxylic acid. Meanwhile, chromium has been reduced to +3 oxidation level. From +6, you have reduced it to +3 oxidation level. So an example would be one decanol so chromic oxide in acidic medium is going to give you decanoic acid. So in fact, chromium in 6 oxidation states, so those oxidizing agents with chromium in 6 oxidation states are very good oxidizing agents. So chromium 6 are very good oxidizing agents. They remove hydrogen from organic compounds and they themselves are reduced to green chromium 3. So as they reduce, they are going to oxidize alcohols or aldehydes to carboxylic acids. So let us go over a few of these oxidizing agents. For example, so polymer chromium oxide is a very good oxidizing agent. It reacts with water and water breaks up the polymer to give you chromic acid. Note that this is also still in its 6 oxidation state. Another very famous oxidizing chromium 6 oxidizing agent is this one. So this is pyridine chromium oxide complex. Which is popularly known as Collins reagent. Few other chromium 6 oxidizing agents are PCC, that is pyridinium chlorochromate, so this is PCC, pyridinium chlorochromate. So this is very unstable. PDC, which is pyridinium dichromate, is stable and it's a very good oxidizing agent. This is pyridinium dichromate. So this is PDC, dichromate. All of these are excellent oxidizing agents. So all of these can oxidize alcohols. To aldehydes. Which can further be oxidized to carboxylic acids. The symbol O, which is here, indicates unspecified oxidizing agent. So if you come across the symbol anyway, it indicates unspecified oxidizing agent. Primary alcohols can also be oxidized to carboxylic acids using calcium hypochlorite or sodium hypochlorite. So this is a primary alcohol. So this could be oxidized to carboxylic acid using calcium hypochlorite, CaOCl twice. With these reagents, primary alcohols can be oxidized to carboxylic acids. Another very powerful oxidizing agent is potassium permanganate, KMnO4. So let us go over oxidation of aldehydes